2.3, the last part of 2.3, complex conjugates. 2.3. Okay, so complex conjugates. Okay, so do you remember when you have a fraction that says 3 over 1 plus radical 2? Can you have a fraction that way? Why not? Because I can't have a radical. So if I have a fraction that says, oh, I don't know. Let's just say I have a fraction that says 4 over 7 plus 2i. Can I have that? What does the I represent? An imaginary number, which comes out of a what? Well, it does represent a negative one. But it comes out of this radical here. So if I cannot have a radical in the denominator spot, can I have an imaginary number in the denominator spot? No. No. So we're going to use the complex conjugate to get rid of it. The complex conjugate is the opposite of what it is. So instead of being 7 plus 2i, it would be 7 minus 2i, so that the middle cancels out. So you're going to multiply the top and bottom by 7 minus 2i, which means you either have to FOIL or distribute. Okay, so we're going to look at some of those this way. I want to know... Okay, it says multiply each complex number by its complex conjugate. And when you multiply by the complex conjugate, you're always going to get a whole number. So what would I multiply 1 plus I by? What would you multiply 1 plus I by? 1 minus I. So to multiply by its complex conjugate, I'm multiplying by 1 minus I. Now, you can cheat a little bit on this, and you don't have to FOIL all the way. All I need to do is multiply the first and the last together. So if I multiply this together, 1 times 1, I get 1. If I multiply I times negative I, what do you get?
I.
Negative I squared. What is I squared? So I have 1 minus negative 1. So I get 2. That's my complex conjugate.
Wow. Never would have got that.
What happens if you have 4 minus 3i? What do you need to multiply that by for the complex conjugate?
4 plus 3.
4 plus 3i. So once again, you don't have to FOIL all the way because the middles will cancel. What's 4 times 4?
16.
What's negative 3i times positive 3i? Negative 9i squared. What's I squared? So I have this. So I have 16 plus 9, which is your complex conjugate. Okay? That then allows us, the complex conjugate then allows us to solve for fractions. So if you have 2 plus 3i, if I have 2 plus 3i over 4 minus 2i, how would you solve this using a complex conjugate? What would you need to do? Multiply top and bottom by 4 plus 2i. Okay, so on the bottom, I can cheat and just go make 4 times 4, which is 16, negative 2i times positive 2i, which is negative 4i squared. Up top, though, I have to FOIL. 2 times 4 is 8. 2 times 2i is, and 3i times 4, 12i, and then 3i times 2i squared, or times 2i, 6i squared. Now, I'm going to replace the I squareds with -1. So I have 8 plus 16I plus 6 times -1 over 16 minus 4 times -1. -6 and +8 gives me 2 plus 16I on top because I write it in standard form. And then I have 16 plus 4, which gives me 20. They're going to separate these fractions and reduce them. So you have one fraction that is 2/20 plus 16I over 20. When you reduce 2/20, you get 1/10. And then it's going to be plus 4 goes into 16 and 20 plus 4I over 5. That's going to be your solution. Always reduce. That is using complex conjugates. This is what you're doing on your homework tonight. You're going to multiply by the complex conjugate to get a whole number, and then you're going to solve fractions with complex conjugates.